All right, algebraic expressions. So basically we're taking the words and writing it in numbers and symbols. Or we can take numbers and symbols and write it in words. Okay? So it can go both ways. Words that indicate addition. What words mean addition?
Add.
Add.
What?
So add plus sum. Now, what's sum actually mean?
The equal.
The answer, yeah.
The answer.
So that one could be a little different at times, depending on how it's used. Okay. If it's just one operation, it doesn't mean anything else. Okay. What else? Anything else? More than? Okay. Alright, so we'll go from there. What about subtraction? So minus,
Difference.
add, or what?
Subtract.
Subtracted, right?
Difference. Is that one?
Difference is the answer, right? Less than. Put a star beside less than. Okay, you can circle it, whatever, it's special, we'll talk about it later. Okay, alright, that's good enough for that for now. What about multiplication? Products.
Wait, watch out.
Again, that's the answer to multiplication. Times. Multiplied by. You could have like a special one, something like doubled or tripled would be what? Like, no? Times 3, right? Double would be like times 2. So there's some little ones like that. You could have double or triple. So double times 2 or triple times 3. You won't see those very much. Okay. Alright, last one. What about division? Yep, divided by. What's the answer to division? Sum, difference, product, quotient. Again, that's that answer.
How do you spell it?
Quotient. Okay. Anything else? How can we write division? As a fraction. So I could say what? Over, right? 2 over 4. That means fraction, but that still means division, right? So you could say something like over. All right. I think that's probably good enough for that. Okay. All right. So that's as a fraction, right? So that's what we're doing. We're taking these words and now we're going to write these expressions out. Now, for the most part, you can just write it as it's given to you, okay? So, number 2A there, 31 more than n. Now, to be technically correct, it would be n, and I'm adding 31 more. Okay? So n plus 31. Now, does it matter what order I add numbers in? No. So in this case, because it's just addition, you could have 31 plus n. That would have been okay. Okay? Now letter B though, 25 less than B. So remember we talked about that star. Okay, less than a star. So less than means subtract. Okay, 25 less than B. Okay. This one here you have to change the order. So in this case when you see less than, change that order. B has to come first, then minus 25. So what would letter C then be? 12 is less than K. K minus 12. Good. When you get to the answer type problems, when you're using these sum, difference, product, quotients, okay, they're going to be written similar to this. Indeed. The product of 4 and R. Well, product means what? Multiplication. And what am I multiplying? 4 and R. So you could put 4 with a point R. You could just put 4R since it's a number and a variable. Okay. Don't want to see this. I don't want to see. What's that? 4XR, right? That's not 4 times R, that's 4XR. Okay? Picky on that one. You can use the dot, or really this is the one I'd like to see. Just this is the one I'd like to see. Okay? E, the product of 5x and y. Product means what? Multiply. And what am I multiplying? 5x and y. So 5xy. Done. So here they get a little bit trickier now. F says the sum of the product of a number x and 2 and 5. Okay? A couple things going on here. We have sum, which is addition, right? Then we have product, which is multiplication. What am I multiplying? X and 2. So 2x, that's my product, right? Now what am I adding? I'm adding the product or the answer and 5. So the answer to this and 5. 2x plus 5. Now, because of order of operations, what comes first? Multiply or add? Multiply. So I don't need parentheses because I'm going to get that answer first anyway. Does that make sense? Okay? If it was flipped around, I would need some parentheses in there. Okay? Alright, number G, letter G. Says the product of 7 and the sum of a number x and 15. Okay? So this is kind of what I was talking about a little bit. So we have product, which is multiply again. So what am I going to multiply? 7 and what? The sum. Right? So I'm multiplying 7 and the sum. Well, what's the sum? Sum of what?
We don't know.
Yeah, x and 15. So x and 15, I need that answer before I multiply it by 7. So 7 times, and then parentheses, x plus 15, because of order of operations, okay? I have to get this answer to be able to multiply it with that 7. And then this might be like a word type problem here. So Jenny had $153, but she's spending $8 per week. How could I write an expression for this? 153, well, she's spending $8 per week.
So
Minus, so minus 8 times the weeks, right? So per, we can add that to our multiply. Per means multiply. Okay? So 8 times x. So if you want to add that to your multiplication, per, we can squeeze it right in there. Okay? So per means multiply. So flip it over to the back. Here's the other part we're looking at. Like terms. Okay? What does it mean to be like terms? Same variable. One more thing. Same variable, same what? Nope. Look down below at these. Same variable, same exponent. Boom. So same variable, same exponent. If it has the same variable, same exponent, we can combine them using the sign in the front. Okay? So simplify the following expressions by combining like terms. And then evaluate given these two values. Okay? So we're going to simplify first, and then we're going to evaluate. So if I simplify this, I'm looking for same variables. So R, and R. So I can combine all three of those. And again, when we're combining, we're adding and subtracting them. Okay? So 2 minus 4 is what? Negative 2 plus 1 is? Yeah, negative 1. So negative R. 9 just comes down. So there's my simplified expression. Okay? And then we're going to take our 3, because R is 3, and we're going to plug it in. So I have negative R plus 9. We're going to plug that 3 in. So negative 3 plus 9 gives me negative 3 plus 9? 6. And we're done. Okay? So simplifying, evaluate. Good. Letter B. What can I combine? The x's, right? Plain x's. 3x and negative 6x. What's that give me? 3x minus 6x. 3 minus 6 is what? Negative 3x. And I have x squared, right? So 9x squared plus 4x squared, 9 plus 4 gives me 13. Now, standard form says highest exponent comes first. Okay? If I have two different variables, okay, alphabet. So whatever comes first in the alphabet comes first. Okay? Highest exponent first. And then work your way down. So 13x squared minus 3x. So again, then we can take this plug in my 2 because x equals 2. So now I have 13. And again, wherever there's an x, you probably want to put parentheses in there. So 2 squared minus 3 times 2. Now if we simplify this then, 2 squared is what? 2 squared is what? 4. So 13 times 4. 3 times 2? 6. What's 13 times 4? What was it? I think you were right. 52? Is that what you said? That is correct. And 52 minus 6 gives me 46. Alright, letter C. Be careful with this, okay? So if I have addition, subtraction, top to bottom, okay? I can't just say, look, 3x, 3x. It doesn't work that way, okay? So if I have addition and subtraction in there, I can't just cancel top to bottom with what I have, okay? But we can still combine like terms on top and combine like terms on the bottom if we have them, okay? So here I have a 6x to the third and an x to the third. So what's 6 plus 1?
7.
7x to the third. 3x is just going to stay up there on top. 2 minus 3x, nothing combines there, so we're going to leave that in the bottom. Okay. And that's it. Can't do anything else. Okay. So there's addition, subtraction in here. It has to be the same. Okay. So if I would be able to cancel anything, I would have to cancel this whole 2 minus 3x. Okay. Does that make sense? So it would have to be 2 minus 3x on the bottom, 2 minus 3x on top. Okay? So I can only cancel things top and bottom that are being multiplied together. Okay? And when they have addition or subtraction in here, it doesn't work. Okay? Alright, so let's take our x now and let's plug it in and evaluate. So x again, still 2. So x is still 2. So we have 7 times 2 to the third plus 3 times 2 over 2 minus 3 times 2. Alright, I want you to solve this. Remember, get the top to one number, get the bottom to one number, then divide. Let's see what we get. So here's our answer. So 2 to the third is 8. 7 times 8, 56, plus 6 is 62. So there's my top number. On the bottom, 3 times 2 is 6. 2 minus 6 is negative 4. So carry that negative 4 over. 64 or 62 over 4 simplifies into negative 31 over 2. And half of 31 is 15 and a half. So negative 15 and a half. Either one. Okay. You can either leave it as a fraction. You can put it as a decimal. Don't care. Alright, we got one more word problem here. What? At a fundraiser, adult tickets were sold for $8 and child tickets for $2. Write an algebraic expression for the total amount of money to be collected. Find the amount of money collected if 200 adult tickets and 300 child tickets were sold then. Okay? So, we're going to do two parts. Write the expression and then figure out the amount of money, if that's given, right? So what expression can I write? Okay, adult tickets sold for $8 per ticket. Child tickets are $2 a ticket. What expression can I write here? What? Multiply. What am I going to multiply? Yeah. Eventually we'll get to this, right? But let's write that expression first. And let's use maybe 8A for adult tickets, right? Plus 2C for children, right? So 8 dollars times adult tickets plus $2 times the number of child tickets, and that will give us our answer, right? So that's our expression. So that's the first part. Then it says, well, what if you sold 200 adult tickets and 300 children tickets? How much would we make? So we're going to take those values. Well, adults, my A value, child's my C value, so we're plugging in. 8 times 200, 2 times 300, 8 times 200 is what? 1600, 2 times 300, 600, 1600 plus 600 is 2200, $2,200. So ticket sales would be $2,200 if we sold 200 adult and 300 child tickets.